In this section, we've been looking at trying to use trig identities to manipulate an angle that isn't quite what we want. It's close, but we want to relate it to something that we have on our unit circle. So we're going to look at one more of those. It's called a set of formulas called the half angle formulas. So the issue here is that we have an angle that is not on our unit circle. It is not one that we know off the top of our heads. But we notice that it's half of one that we do. So before we saw we had double the angle that we wanted. We said, hey, this angle's twice as big as one of them on the unit circle. Well, in this case, what we see is we have an angle that's half what we need off the unit circle. So these formulas here, I don't have them all memorized as always. They're on your formula sheet. But they're derived by using the power reducing formula. If you use a power reducing formula and instead of just an angle in there, you say, hey, I want half of that angle, it derives down. Now, we have to be careful because when we take the square root, it's going to be plus or minus. So we're going to have some of those issues again where we have to take a look and say, hey, what quadrant are we in? Now, hold on, let me go back here. Now, notice these, there are some versions of tangent down here where they involve sine and cosine. But notice that all of these, to use them, what we're going to want is the cosine of the full size angle that we could get off our unit circle. So in all of these versions, what I need is the value of the cosine. So for instance, we're going to see in a second, suppose I wanted the sine of 15. Well, I don't have 15 on my unit circle, but I do have 30. So what we're going to need to do is use the cosine of 30 in order to manipulate these formulas. Okay, so this is exactly what I was telling you here. 15 is not one that I know. It's not on my unit circle, but it is half of one I know. So what we're going to do here is we're going to think about, okay, this 15 is half of 30. So here I've got half of 30 being manipulated. That's 15. Now the formula requires us to know the cosine of 30, but we know that. It's on our unit circle. Okay, so we're just plugging in and chugging here at this point. Just be careful. So here they've got a common denominator. They made 1 into 2 over 2. Do you see how we got here? So this is the same as 1 over 1. You can make them both 2 over 2. That's how we got here. Now, if you have a fraction divided by a number, the 2 is going to join the bottom here. It's keep, change, flip. It's like he's 2 over 1. You'd keep the top, change it, flip it over. But what's going to wind up happening is I'm going to multiply the 2 times this 2 down here. Okay, now I had told you that we have to be on the lookout for plus or minus because we have a square root. And that's true, typically. But they told us, we know where this angle is. The angle we're looking for is 15 degrees. That's in quadrant 1. So a sine in quadrant 1 is, sine is a y, so that's a positive. So I didn't need to worry about it here. Okay, yeah, one last step. So remember, if I've got a fraction inside of a square root, I can square root the top and the bottom individually. That's how they got it down to here. Now, I know this is a very weird looking number with a root inside of a root, but that's okay. That's good enough. All right, now this is going to be more typical. That was the basic, like, can you just plug it in and crunch it? What we want to know here is they're going to tell us that we have this tangent of this angle. This angle makes a tangent of 8 over 15. They're telling us what quadrant we're in, which we're going to need to know in order to deal with that plus or minus. Now let's get started here. So what we're going to be looking for is the value of all of the half angles. So we're not interested in the angle they've given us. We want to know something about the half angle. Now let's talk through how we would do that. I have the tangent ratio, which is the opposite over adjacent, which is the y over the x. But because it's in quadrant 3, the y and x are both negative. So I hope you're comfortable with this at this point. So because we're in quadrant 3, x is negative and y is negative. They've both gone so back and down. So I don't like how they do this here. I like to put it, I don't like the points. It's the sides of a triangle. So here are my sides of a triangle. We would use the Pythagorean theorem to come up with this third side is 17. Just 8 squared plus 15 squared equals c squared. We would get 17. Okay, now we have a complete triangle. Okay, so what we need in order to use the half angle formulas is I need the cosine. Well, they've got a tangent here too, so we might need sine. So they've found this is my triangle. The sine from this angle would be -8/17, opposite over hypotenuse. And the cosine would be adjacent over hypotenuse. Okay, now why are we doing this? Because to use the half angle formulas, we have to have the value, particularly of cosine, but since we're doing a tangent, we may be able to use this as well. Okay, so I have everything I need. Now there's one more thing that we have to take a look at. Yeah, this is very confusing, but let me go back here to show you. All right, now this triangle was built off angle alpha, but we don't want angle alpha. It's giving us useful information in order that we could find this cosine that we're going to need. But the angle we're interested in is alpha divided by 2. And it is not in the third quadrant. It is not this same angle, and it is certainly not an angle in this triangle. It can't be. So this is alpha that's built off going all the way around here on the circle. Alpha divided by 2 is in a different quadrant altogether. So here's what we're saying. We know that alpha is some angle between pi and 3 pi over 2, between 80 and 270. Do you agree with that? We don't know what it is, but we know it's somewhere in there. Well, our angle is going to be half of that because it's half the angle. So we're somewhere between, let's divide both of these by 2. So we're somewhere, the angle we're interested in is somewhere between 90, half of 180, and between 135. So somewhere, this is 180, so between 90 and 135, it's somewhere in here. So, one more time. I have built this triangle based off alpha. And that's been useful because I need information based off of that, because that's how the formula works. But our angle is not in the same quadrant. It's half. So this angle is in quadrant 3, but ours is not. So if we think through the logic, if this is in quadrant 3 and we're half of it, that puts us somewhere between 90 and 135. You see, I just cut quadrant 3 in half. So I'm somewhere in quadrant 2. Now, why is that going to be important? Because when we use the formula, we're going to need to know whether or not sine or cosine, what the value sine or cosine takes in quadrant 2. So that's what all of this is explaining up here at the top. It's saying, hey, we're cutting it in half because alpha, we don't want alpha, we want alpha divided by 2. And it tells us we're in quadrant 2. Okay, so the first thing they wanted is sine of alpha divided by 2. Here's our formula. We know the cosine of alpha because we got it from that triangle. Now we crunch all of this down. Just some basic stuff, getting a common denominator here, all of those things. Just basic algebra. But we get to this point here where we've got plus or minus. Notice that well, let me show you here. Remember, you got a square root with a fraction. You can square root the top and you can square root the bottom. And then they rationalize the denominator by square root of 17 over square root of 17. Now, why did they select the positive? It was a square root. We could do plus or minus. Well, this is sine, and we know alpha over 2 has to be in quadrant 2. A sine in quadrant 2, a y in quadrant 2, a y value is positive. So we settled on that. Okay, let's do it again here. We want the half angle for cosine. Here's our formula. Our original triangle, the triangle based off alpha, told us this value. Now, we just have some basic, I don't even know if you call it algebra, arithmetic here to do. So they're just showing that this is keep, change, flip. It's going to wind up, the 2 is going to multiply by the 17. Well, they reduced it, so get this. Okay, now, they square root of the top, square root of the bottom. They jumped over this. They rationalized all of this. So this is like 1 over the square root of 17 because you can square root the top and the bottom. They rationalized the denominator. It's got us here. Now we have to settle on the plus or minus. Well, we have a cosine, and we know our half angle is in quadrant 2 over here. So x values are cosine, and we're in quadrant 2, so we get negative. Okay, last one here. We have a tangent. This is going to, well, yeah, there are alternate versions of this formula that might have needed the sign, but we're going to use the one here, at least they're going to use the one here that uses just cosine twice. So we just crunch that, manipulate it down. We get to here. So this is the square root of 16, and it is 4. Now, how did we settle on negative? Okay, well, it's a tangent. We know this half angle is in quadrant 2. In quadrant 2, x's are negative and y's are positive. Cosines are negative, sines are positive. So that's a plus and a minus is going to be a minus, because tangent is sine over cosine. So we'll have one plus and one minus, which will multiply out to be a minus. Okay, let's do it again. They only want one of these here. So we have an angle. They tell us we're in quadrant 4. So we're going to work with alpha, because this formula is going to need the cosine of alpha. It's just what the formula requires. So let's get started with this, and we know that we've got a sine of this angle is negative 4 over 5. Now you could Pythagorean theorem this. A squared plus b squared equals c squared. This is a special triangle that makes a 3 there, a 3, 4, 5. So I know that the value of this missing side is 3. Okay, now we are somewhere between 270 and 360. Do you see that alpha is in quadrant 4, so it's somewhere in there? Well, if we cut this in half, because we want a half angle, if I cut this in half, I'm going to be somewhere between 180 and 135. Just cut 270 in half and 360 in half. Because again, I don't want alpha, I want the half value. So where's the half angle at? Where is alpha over 2? Well, do you see if we're between 135 and 180, we must be in the second quadrant. Okay, now let's just do the math. So, sorry, I don't have these memorized. Sorry, I think that was plus, wasn't it? Okay, so here's my formula. Now, the reason I worried about this original triangle with the alpha is because that's what's going to give me the cosine. Now, here's our triangle. This is alpha. The cosine in this triangle is adjacent over hypotenuse. It is 3 over 5. So that's what I need. I've got 1 plus 3 over 5, all divided by 2. Now we're just going to manipulate this. I'm going to do it over here at the top. 5. I'm going to turn 1 into 5 over 5. See, I just turned 1 as like 1 over 1. I got a common denominator so I could add these fractions. And so what I've got now is plus or minus the square root of 8/5 over 2. Now, this is keep, change, flip. It's like 8/5 times 1 over 2. I can reduce this, and I'm going to wind up with 4/5. So I've got plus or minus the square root of 4/5. Now I have a fraction underneath a root, so I can turn this into plus or minus 2 over the square root of 5. I can rationalize that denominator by multiplying it by the square root of 5 over the square root of 5. I'll get 2 square root of 5 over 5. Okay, now we are taking a cosine, and we are in, it's alpha over 2, so alpha over 2 is in the second quadrant, which we've reasoned our way through that. So cosines in quadrant 2 are negative. So our final value here would be negative 2 radical 5 over 5. Okay, one last question here. They're just telling us that this was a problem in the book here. What they were saying is, suppose we knew that there's the professional skateboarding ramp has got this angle here, alpha. Well, we want to know what the angle should be if it's half of that. So I guess, so the non-pros or whatever, the amateurs use a ramp that's theta divided by 2. Okay, so here's what we've got. We know they've told us that the angle, the tangent ratio is 5/3. So I've got a ramp that has a tangent, an opposite, a sine over cosine of 5/3. I can use that to find the hypotenuse, and here's what I've got. So I've got a complete triangle. Okay, now let's find, if we're going to find tangent of theta divided by 2, what we're going to need is cosine of theta, just because the formula always requires that. So we go back to that same triangle there. Cosine would be 3 over the square root of 34. They rationalized it. So here's all I need. To find the tangent of theta divided by 2, all I need is this. I need the cosine of theta. So I put it in there. We got a lot of manipulating to do. Just making 1 to turn into 34 over 34. Okay, we keep change flip, get all this down. We've got some very weird looking number inside of a square root. If I crunch this on my calculator, I get that the tangent of theta divided by 2 has a ratio of 0.57. Okay, well, I wanted the angle that this amateur ramp would be. So I wanted to know the angle that has this tangent ratio, because the angle that has that is my theta divided by 2. So all I need to do on my calculator is inverse tangent of 0.57, and the angle is 29.7 degrees. Okay, so a little application there. I hope that made some sense. Basically, they told us the tangent ratio. They told us the tangent ratio here, and then we used that information to figure out what the value of a half ramp should be for the novices or whatever they are. Okay, I hope that section made sense. It was one last chance where we didn't know the angle that we were working with. In this case, it is half of 1 that we know from the unit circle.